I've put together a series of small video clips that I made 7 years ago on BMW motorcycle rear drive rebuild, and my bike is a 1938 R51 Boxer. It has the exposed drive shaft, as you can see here, so that would be suitable for the R51/2/3 and other bikes in the 50s, and possibly inspirational for later bikes. Now, I'm not a mechanic, I'm an enthusiast, so this doesn't come with any guarantees, but hopefully you find it useful. When I bought the bike, the drive was quite noisy and whining, and the owner recommended additives. 2 years later, I took it to bits to find incorrect shimming and chipped pinion teeth. Back then, in 2015, the crown wheel and pinion cost over $1,000 for the genuine BMW parts, but the Chinese parts were only $40, so I bought them to see how I would go, and I think the result was quite good because the noise went away, and 5,000 kilometers later, it going just as well. So here are the video clips. I hope you find them useful. This is the diff casing. Oh, not diff, there's only one wheel. It's the rear drive casing for the 1938 BMW R51. All the BMW pits are at the top of your screen. Flange drive is Chinese, mind you, and all the Chinese bits I just got from Ralph at MH in Shanghai are there. There's a little bit of rust which I can clean up, and I think that'll be okay on the ring gear, but let's see if we can get them all in there and fitting correctly. And being old stock, new old stock, the pinion rollers were a bit rusted, so they need a bit of cleaning up, probably a bit pitted, but I think better than what was currently in there. And the base of this central needle bearing carrier was a little bit corroded on the outside. I've just pulled that down with a bit of emery. Not perfect, but probably not too bad. So these are the old needle bearings, and there are 4 extras which Ralph gave me for the Chinese implementation, which is 45 rather than 44 needles. Now, this is with the BMW original bearing outer, which presses into the shaft. It's a really nice fit over my needles, which you can now see, carefully placed in there with high temperature bearing grease. Here's the part which had the pitted top, the Chinese part, and lots of play there, which is not going to be very nice, so I'll stick to the original BMW one, which seems to be a much better dimension. And now that's going to get put into the housing right now. And it's a good thing that we have the original part, although it may not be original, it might even be Chinese. Otherwise I'd have had to have made one in the lathe over there. But first of all, here's the original one. It came with my housing, which is just about to be pressed into the housing after I've given it a bit of heat. And there's a groove with some oil holes there. You can see one at the far side of the picture, which I'm going to line up with the pinion hole. It probably doesn't matter too much, but to excuse the lack of focus, we'll get there. So that part's nicely pressed in there, and what I now have to do is drop the housing over there so that the needle bearings are inside and the ring gear can engage with the pinion. Then we'll probably have to pull it apart a few times to get the shimming correct for getting good tooth contact between the pinion and the ring gear. So when you look at the instructions in the workshop manual you'll find online, you'll see a 77 in the middle of your page there. That's the target that we have to get for the distance between 2 points, as you can read in the instructions. So I've measured up the distance to the center, the extra bit in the housing, and what I've got in my pinion. I get 75.1, which means I need to add 1.9 millimeters of shims in order to get the right positioning of the, let me get out of the shadow, and there I've got 1.9 millimeters of shims supplied by Ralph, ready to put the bearing on and put that in and see if we get a correct positioning for the pinion. We'll check all this eventually by putting engineer's blue on the gears and spinning them and see if we get appropriate tooth contact. And you'll probably see there is a cutout there at the bottom of the diff housing where the pinion goes in, and if we look on the actual gear itself you'll see there's a cutout on the outer rim of the bearing, and that should coincide, I presume, don't see any instructions, to help oil to drain back into the diff rather than directing it towards the universal joint and getting a leak. Just to help, I think that is. So we can just have a look here at what the problem with this rear drive was. There were no shims in here before, which meant that the pinion was probably, I've got 1.5 mils of shims in there now to get the pinion such that the distance between this shoulder right at this point here and the centre of the drive is 77 millimeters. We looked at that earlier. No shims before, meaning the pinion wasn't far in enough, which means the teeth didn't engage, and that gave chipping of the teeth on the old pinion. What we're about to do now is test the engagement of the teeth. So what I do is I cut the outer 2 rows off a toothbrush and use that to apply bearing glue or engineer's glue to the teeth. We'll put it back together and give it a spin. This thrust washer here, brass or phosphor bronze, is a little bit too thin, but we'll fix that by pushing hard on that to make the whole ring gear assembly come up hard against this washer here, this shim on the drive housing. I don't think that's an original shim, doesn't fit very nicely, but I'll get a new one once I work out what all my shim spacings have to be. Okay, and I have found a 3/8 Whitworth socket, fits very neatly over that drive, so we can spin it nicely and see what the teeth markings are. And you'll find in the manual a guide as to where the teeth should be. Basically, you want to get nice contact in the centre of the teeth, not getting out to the edges. So now we've got the cover bolted on with the ring gear and flange in there. And as I noted before, that brass thrust washer is not thick enough, and you'll see this move in. You probably heard it as much as anything. The play there originally was 0.79 millimeters, and it should be 0. 0.05, and then when you tighten up the gasket, it tightens and it takes up to essentially no movement. So I pushed that in, which will emulate putting in a proper thickness of thrust washer there. If the back play on that, which looks quite good to me, is appropriate, I'll measure that later. Then everything's okay. All I need to do is work out, put a dial gauge in this, see how much thicker I need to make that washer so that stays down. And now I'm going to spin this and I'll look to see what the tooth pattern is looking like. It's going for a little ride. You can see the tooth contact pattern is looking pretty good there. It's pretty well in the centre of the tooth, a little bit too far to the inside perhaps, which means that I take this action here to reduce the distance from the pinion to the disc gear, which means that I need to add just probably 0.5 mil or less, no, definitely less, quarter or to 0.2 of a mil to these shims to put the pinion a little bit closer in. Now I think I'm getting a pretty reasonable tooth contact pattern. That's with using 2.06 mils of shims behind the pinion here, and that's giving me 0.19 mil of backlash. The tooth pattern is still a little bit close to the inside, closer than probably have been absolutely ideal, but that may be the fact that I can't get any more adjustment out of it, because if I use any more shims, for instance at 2.33 mils, oops, there's the wind, I had binding of the pinion against the needle bearing in there. So I think I've got it just about as good as I can with Chinese parts inside a BMW case. And I ended up using a 2.2 millimeter thrust washer. It used to be 1.95 by my measurement. This shim here, a 1 mil shim from Mark Huggett in Switzerland, and that ended up giving me no end float in the ring gear, whereas before, when I got the bike, it had been set up with a 0.79 millimeter end float, which was causing all the problems, and also there were absolutely no shims behind the pinion, with what looked like the same pinion and gear, Chinese ones, and obviously we need to set it up in order to get it to work with the correct tooth contact. Hopefully it'll be quiet, and it probably has slightly different dimensions to the original BMW part, which is why I've got to go to the extreme with shimming the pinion before I get a reasonable tooth contact pattern. We'll put it together and see how she goes. So I've hit a small snag on reassembly, not too bad. The old pinion here just for reference, and you can see chipped teeth, just in case I hadn't shown that earlier. What's happened is that we've pushed that pinion, the new one, 2mm further in. It means that this flange here doesn't quite get it over to articulate with the hole in the pinion. So what I'll do, rather than take some material off the inside of the flange so it would go in a bit further, this pin which goes in this way, I'll put a bit of a flat, I'll extend that flat on this side so that it can actually get in there nicely, and that's a bit better than doing a bit of butchery to the end of the flange here. So that was the only problem so far on reassembly. Cheap way of getting backlash, or the articulation point, I've got about 16mm from centre, so I can do that here. And my backlash has gone up from 0.19mm to over 0.3mm after running in for about 10 miles with an oil, two lots of oil going through in that time. Metal in the first lot, not so much in the second, so it's running in. But these Chinese gears have got serrations, this is the old one, tend to have quite a bit of serrations, so they're not being lapped in, and so it's expected that you get something like that happening. And on my first run, I did get quite a bit of an oil leak from this area, and I was a bit worried it was coming down the splines and that I needed to seal this flange over the splines with silicone or so, but no, it was coming from in here. There is a bit of a recess in the threading, and it was enough of a hole left to let oil come through, so I just put a bit of silicone in that, and I'll do a proper job on that, I think, if I have to pull this out, but probably worth remembering to put a little bit of a sealer in there so you don't get that leak that I did. And importantly, I wasn't getting any kind of a leak from the seal at the other end of the drive flange. No oil at all coming through this hole, which used to be a problem. That's the overflow from that flange, which is caught in a slinger.
So there you have it. 7 years and 5,000 kilometers later, the oil is clean, the rear drive is not noisy at all, and I'm very happy with the outcome. If I were to do this again, I probably would use genuine parts, and that's probably a reflection of 2022 rather than 2015. Next episode perhaps is the engine rebuild. Here you can see what is the front end of the crankshaft, and this slinger plate or thrower plate sits in the top there, and oil by centrifugal force fills up and spills into where the big end is. Here is the thrower plate from the rear of the engine with a protrusion which is intact, but on a previous rebuild by the previous owner this was broken, and he has reused silicone to attach the thrower plate and to try and make a connection. The result was that these two holes that by centrifugal force send oil into the big end were blocked, and this is the result, which was rather disappointing. So with help from my Malawian friend in Switzerland, I've got good parts and good service, and just waiting on new slinger plates which are being remade in order to complete the engine rebuild. Thank you for listening.